talking about, well, we've already been talking about trends, but now we're going to talk about some few trends at the very end here. Um, First off, um, valence, of course, we know that increases from left to right, and we know that it goes from 1 up to 8. We skip the transition metals, so it increases from left to right. It doesn't change going down a column. And density and melting point, basically, they increase towards the center of the periodic table. So you have your higher density elements and your higher melting point elements in the transition metal section. And then the last 4 that you need to know are going to be atomic radius, ionic radius, electronegativity, and first ionization energy. So let's do atomic radius. The distance from the nucleus to the outermost electron is considered the radius, and the way that they do that is you have one atom's nucleus here, you have another atom's nucleus here, and they take the distance between those two values and they cut it in half, and that's usually measured in picometers if I recall, but it's actually not directly measuring. Obviously we couldn't do that, but you can measure from one nucleus to another, and you take that number and cut it in half, and that gives you your atomic radius. So as far as the trend, it increases going down a group, and if you think about the periodic table as you go down a column, what are you adding? Well, you're adding energy levels. And we learned earlier that an increase in the energy level, it means it's farther away from the nucleus. So if I have an electron that's, say, here, and I have an electron that's, say, here, and this is my nucleus here, then obviously this electron is in a lower energy level than this one. So if this was, say, sodium's electron, it's not as far out as, say, barium's outermost electrons. So that's pretty easy to see why the radius gets bigger as you go down a column, is because you're adding energy levels. You're getting farther away from the nucleus. Now going across a period from left to right, it's a little harder to see. The first thing we have to understand is that going from left to right, we aren't adding energy levels, we're only increasing the sublevels. So if I go across row 2, for example, as I go across row 2, all the electrons that I'm running into are in the second energy level. They're not getting farther away from the nucleus. So that's easy enough to see why it doesn't increase. But why does it decrease? Well, as you go across that period, you see, as you go across, what are we adding? Well, we're adding electrons, and we're adding protons. 3 there, 4 there, 5 there, 6 there, 7, 8, 9, 10. So what's happening to our nucleus as we go from left to right? Is it getting more positive? It is. And why is it getting more positive? Because we're adding more protons. Remember, increase in atomic number, increase in proton number. So, if we're increasing the positive value of the nucleus, and that outermost electron isn't getting any farther away, what do you think it tends to do to those electrons? It pulls them in. And when it pulls them in, what does that do to radius? It makes the radius smaller. So as you go from left to right, the atomic radius of an atom increases. Excuse me. say that again. As you go from left to right, the atomic radius of an atom decreases because the proton value, the positive value of the nucleus, is getting more and more as you add more protons. And since the electrons aren't getting any farther away, that causes them to be pulled towards the nucleus. All right, so that's atomic radius. Part 10 of our PowerPoint.